Today, we're talking about a really fascinating new system called Structura. At its core, it's a new way to measure order and chaos in images. But its real power is in seeing something that's usually invisible, that exact moment when a system is about to break. So let me ask you a question. It kind of sounds like a riddle, right? What could an earthquake, a stock market crash, and a hurricane possibly share? I mean, they seem totally unrelated, but they all share this one hidden connection, a secret signal that gets right to the heart of what Structura is looking for. And here it is. The answer is something physicists call crackling noise. You can think of it like the sound of ice cracking before it gives way. It's a series of small, almost predictive pops and fissures that tell you stress is building up. It is the statistical signature of a system that's getting ready to make a big, sudden change. Okay, so to find these hidden signals, Structura has to look at images in a completely new way. It's not about identifying the objects in the picture, it's about understanding the underlying forces that are holding the picture itself together. This right here is the absolute key difference. A typical AI, right, it's trained to classify things. It asks, what is this? And it spits out an answer like a cat or a tree. But Structura asks a much deeper question. How organized is this? It's looking for the fundamental state of the system. Is it stable? Is it organized? Or is it on the verge of falling apart? And because it's not looking at what things are, but how they're put together, the system is just incredibly versatile. It can run the exact same analysis on cells under a microscope, a hurricane from space, or even a chart of financial data. The scale just doesn't matter, because these patterns of stress and organization are universal. So you're probably wondering, how do you actually measure something so abstract like organization or stability? Well, what Structura does is it plots every system it sees onto this really simple but incredibly powerful two-dimensional map. Now, I know this looks a little complex, but the main idea is actually super simple. It's all right here in this chart. Structura measures everything along two axes. First, you've got the vertical axis, stability. Is the system stable and happy, or is it critical, meaning it's under stress and about to break? And then there's the horizontal axis, organization. Are its patterns orderly, or are they just a chaotic mess? This simple grid gives us four key states. Up in the top right, that's where you find normal, healthy systems. They're both organized and stable. But look over at the top left, organized and near critical. This is the real danger zone. This is where you find hidden instability. The system looks perfectly fine on the surface, but it's actually under immense stress. The other two show systems that are either a bit messy but stable or actively breaking apart. But to get the data it needs to actually place a system on that map, Structura has to look at an image from a bunch of different angles all at once. And it does this using a special toolkit of analytical perspectives it calls lenses. You can really think of these lenses like different pairs of glasses. Each one is designed to filter for a very specific type of structural information, things like breaks or flows or complexity. And in doing so, they make these hidden patterns just pop right out. Let's take the Laplacian lens, for example. It's basically a crack detector. So on the left, you've got a normal image of a rock. But when you see it through this lens, you get what's called an edge response map on the right. See all those bright lines? That's the lens finding hidden stress fractures and sharp breaks in the structure, areas of strain you'd never see with the naked eye. Now, switch to a different lens and you get a totally different story. The anisotropy lens is more of a flow detector. It completely ignores the cracks and instead looks for direction. Are the patterns random, or do they have a clear, aligned flow, kind of like wood grain or water moving in a current? This shows you a completely different side of the system's organization. The real magic of Structura isn't in using just one of these lenses. It's in combining the information from all of them to create a single, unified picture. So here's how the whole process comes together. The system takes an image, it analyzes it at multiple scales, and it runs all of its different lenses, the crock detectors, the flow detectors, you name it, all at the same time. But the crucial final step is to combine all those signals to look for patterns across the different analyses. And this is the end goal. All of that incredibly complex, multi-layered analysis gets boiled down into a single, intuitive number, a coupled risk score. It fuses all the data from all the lenses to give you a final verdict on just how healthy and stable a system really is. Now, I know this all might seem a little abstract, but the real-world applications are immediate. They're tangible, and frankly, they operate on a massive scale.
And this is where the scale becomes truly mind-blowing. Structura is designed to plug directly into live global satellite feeds from agencies like NOAA and NASA. What does that mean? It means it can get a structural health check on the entire planet every 10 to 15 minutes. And with that capability, we can apply this deep structural analysis to some of the most critical and dynamic systems on Earth. We can see not just where a storm is, but how organized and stable its internal structure is. We can analyze the coherence of an atmospheric river or the fragmentation of a wildfire plume, all in real time. Which leaves us with a final and pretty powerful question. For centuries, we've been caught off guard when complex systems suddenly hit a breaking point. But what if we now have a way to see that crackling noise, to spot the hidden instability before the cascade really begins? What could we predict, prepare for, or maybe, just maybe, even prevent next?